All right, this is chemistry, week 2-5. Flip charts chemistry 2-5-2021. Video here is chemistry 25ABlake. Might be a second one here today. We're going to start this chapter. Okay, two things. One, we're going from chapter 7 to chapter 8 and then to chapter 9. I suspect going to chapter 9 may be better first, but I don't want to make that decision this year. I want to work with this book another year or two to decide. This is adequate, going 7, 8, and 9. Just 9 may be better. So we're not going to make that jump this year. Secondly, when we go to do three things, I guess. Secondly, when we go to do this chapter, we're going to start with the Lewis structures first, because it's kind of a technique thing. And then we'll go back to the beginning of the chapter and start our way through. You don't need the beginning of the chapter to do Lewis structures. Thirdly, the order that the problems are written isn't the best way to do it. I've only gone through this chapter once and I organized these last year, so maybe this will end up tweaked, but the order we're going to go through is this one, and it's in the following pages in the flip charts: 38, then 41, then figure 14, page 258, then 42, then 40, 39, 43, 44, and then on up to 49, other than 37 is here. The general reason for that is the problems start simpler here and they get more complex as they go this way. So here is how you do a Lewis structure. What we are paying attention to is the center atom. So we'll try to work, not all the examples have one central atom, we will see that. But we're normally going to be paying attention to one central atom. And then we're going to use 6 steps for basic problems. If it's got multiple bonds or charged ions, we have to throw some other steps in there. But most basic problems, you're going to list the atoms and then place the electron dots on them, and then add them to determine the total number, then write a skeletal structure, and we'll add in shared pairs, and then place octets where they should be, and add up the electrons to determine the bonds. This sounds like a lot of steps. But once you do 3, 4, 5 examples, it starts to fall together. If you're honest to God working it and trying, you'll have that system down by the time you get to about here. And the best way to do them is to just do them. So let's do one. The first one is just an example. It's CH3I. You don't need to worry about, is this right? We'll just give this to you. So you list the atoms you have. I have to insert a page. No, I have to do this. Edit, copy, edit, paste. Okay, so I'm going to start with that. File, save. When I'm done, I'm going to not save any of this because these are already in here. I don't want them duplicated. I guess the worst case scenario, I'm going to remove it. So you are going to write down what you have. So you have a carbon, and a hydrogen, and a hydrogen, and a hydrogen, and an iodine. Next step, give everybody the electron dots they need. Place electron dots on the atoms. So you would have to know from the wrong drive here. The flip chart we were using there last week, I think this has one. Right here. You have to know what column your atoms are in and how many valence electrons they have. And the pattern is, we don't need to worry about the transition metals, probably this chapter. 1, 2, 3, 4, 5, 6, and 7. And you don't need to worry about the 8th one because they don't make compounds because they don't react. So 1 through 7. And you put those electron dots in. Carbon has 4. 1, 2, 3, 4. Hydrogen has 1. 1, 1, and 1. And iodine, in the next to last column, the halogens has 1, 2, 3, 4, 5, 6, 7. You know how to do that. We didn't have problems with that. Then, next step, we add them up to determine the total number of electrons. There's 7, 8, 9, 10, 11, 12, 13, 14. Total is 14 electrons. Then you pick a central atom and write a skeletal structure and add in shared pairs. I've kind of got multiple steps there. So the one that's going to go in the middle, if you have carbon, put carbon in the middle. Most of the time you do. If you have something close, if you don't have carbon, but you have something close to carbon, like nitrogen right next to it, or oxygen, or phosphorus right below it, or silicon right there. I guess I was looking at the wrong place. Silicon right below carbon, or nitrogen next to it, or oxygen, or phosphorus. Something grouped close to carbon, put it in the center. Never put a halogen in the center, let's say. Although there may be a case later, but they're weird. So let's put the carbon in the middle since we've got it. Let's just put the iodine here, hydrogen here, hydrogen here, hydrogen here. That's our skeletal structure. Then we put in shared pairs. 1, there's a shared pair, there's a shared pair, there's a shared pair, there's a shared pair. So that was this step. Then place octets where they should be. In other words, you're going to give everybody 8, but there are exceptions. Hydrogen is one of those exceptions. Because on a atom, if this is your nucleus in the center, you got the first level's got 2. Well, that's the level where hydrogen is. The rest of the layers, everybody has 8. But hydrogen only has 2, so hydrogen is an exception. We'll talk about more exceptions later. Iodine gets 8, carbon already has 8. So we got to flesh out iodine with 8. There's 2 more, there's 2 more, there's 2 more. They're shared this pair. Covalent bond is a shared pair. We're going to talk about how they do that when we go back to the beginning of the chapter. For now, all you got to know is that they're shared pairs, and they can do that. Okay? So then, the next step is to add those up to determine the bonds, and then you adjust for multiple bonds and charged ions and draw the Lewis structure. We add, we get 1, 2, 3, 4, 5, 6, 2, 4, 6, 8, 10, 12, 14. So we are done. We're ready. Now we just finish the Lewis structure off by drawing in sticks for the shared pairs. This is covalent bonding, different from the ionic we talked about. Hydrogen, hydrogen, hydrogen. These are shared, or sticks, and the unshared pairs stay. And this guy is a Lewis structure. I got to see how the book does Lewis structure differing from these, but this is typically how it's done. Looks like they did that one that way. Okay, so let's look at the next example. That was just an example. So this is probably 38 coming up. 38, we've got NF3. 38. NF3. You need to do these and learn the process. You can't look at it and, oh, that's what he did, right? No, you gotta do these step by step, one after the other, over and over. Okay, so the first thing is you write down what you have. We've got a nitrogen, a fluorine, a fluorine, a fluorine. Go back to those rules. The next thing is give everybody their electrons. Nitrogen is in the, I'm going to move it a little bit, or I'm going to move these three a little bit. There we go. Nitrogen is in the fifth family, has 5. Fluorine is in the 7th, has 7. Whoops, wrong thing. So nitrogen gets 5. 1, 2, whoops. One, 2, 3, 4, 5. Fluorine gets 7. 1, 2, 3, 4, 5, 6, 7. Repeat. 1, 2, 3, 4, 5, 6, 7. Repeat. 1, 2, 3, 4, 5, 6, 7. Next thing you do is you add them up. That's what the rules say. 7 times 3 is 21, 22, 23, 24, 25, 26. The next thing is, I'll go back and show you. So we listed all the atoms, placed the electron dots, added them up. We're going to pick a central atom and write a skeletal structure. In this case, it's probably the nitrogen. It's the odd one out. Nitrogen's closer to carbon than fluorine is. Then we'll put the octets where they should be and add them up. Okay, so here's the nitrogen. Let's put it in the middle, put the other atoms around it. Put in the shared pairs. 1, 2, 2, 2, 2, 2. There's the shared pairs. Now give everybody 8. There are exceptions. We're not going to see them just yet. Nitrogen gets 8, so 2 more. 2, 4, 6, 8. Fluorine gets 8. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, come on, 4, 6, 8. Then add them up. 8, 16, 24, 26. So this is going to work out. It's a simple enough one. If those numbers don't match, then we have probably double or triple bonds to put in, multiple bonds to put in. So let's put the shared pairs, replace them by sticks. Fluorine with its remaining 6 unshared pairs. Fluorine with its 6 remaining unshared pairs. Fluorine with its 6 unshared pairs yet, and nitrogen still has an unshared pair there. Then this is the Lewis structure. Lewis structure. Let me see how much time I got. Okay, I'm going to stop the video here and maybe do a couple more on another video. Actually, let me put them on here. One more, make this a longer one, because then I cut down on the number of videos. Because I have 5 more videos, I get penalized, but I don't get penalized if they're longer. You'd think it'd be by memory, but it's not. So the next one is NH4+. I don't know what number we're on. 46? 41. NH4+. You're supposed to know what NH4+ is. NH4+ is ammonium ion. Okay, we have to do something a little different this time. When it's an ion, you have another step. So we list everything. We've got an N, and an H, and an H, and an H, and an H. Nitrogen is in that 5th column. Make sure you know how to do this, but the good news is you guys kind of do know how to do this part. There's nitrogen right there, 5 valence electrons. One, 2, 3, 4, 5. Hydrogen gets 1 apiece. 1, 1, 1, 1. Add them up. That's 9 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, if we had extra electrons in this, pay attention, if we had extra electrons in this had an extra negative, you'd have to add another electron in. If you had a 2 minus charge, we'd have to add 2 more electrons in because they're negative. We have a plus charge. What's that mean what we're going to do? Oh, that means we're going to take an electron away. So this is non-mole. Minus 1 electron is we need to shoot for 8 electrons, not 9. So this step is to adjust for charge. All right, the next step is maybe I'll end up reworking these rules here, but we have to adjust for charge when we get to this step. This one's a little more complicated than just a basic one. So we listed all the atoms, we placed electron dots, we added them up, but we had to adjust for charge. Now we're going to write a skeletal structure, add in shared pairs. We don't need this step on this one. We'll add them up and we'll be about done really on this one's pretty simple. Okay, so I've got a nitrogen. Let's put hydrogen here, 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 here. Nitrogen's going to be our simple central atom. It's the odd one out for one thing, but it's right beside the carbon. Okay, then you put in shared pairs. We share here, 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 and here. Then we make sure everybody has 8, but hydrogen is one of the exceptions. They only need 2, and nitrogen gets 8. There's already 8 there. We add them up. We add them up. We get 8 electrons, so we're good. We don't have to worry about double bonds or triple bonds. And now the only thing left to do is put the shared pairs in, or put the sticks in. H, 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 and this one all together shares a positive charge. The ammonium ion does. I think that's the way this book does it. Did I go back here and do this? Yep. This is the way this book does it. They put a bracket around. I was circling those last week, which is another way to do it. It's the way I've been doing it for decades. This book uses the brackets, so what I was circling there last week, you could just replace that in your mind with a bracket. You got the whole ion. Okay, for now, that's where I'm going to stop. The next video will be Chemistry 25B Blake. This one's Chemistry 25A Blake.